reducing balance loan. It's a little bit less expensive than a flat rate loan, but basically, um, as the balance owing decreases when you're like taking out a loan, the interest charged each period also decreases. Okay. And it involves the use of like geometric sequences and series, and it can get a little bit complex. We've got a couple of questions. We're getting towards the end of this lecture, but these last few questions will take a while to go through. So let's go through a question. So Bianca borrows $650,000 to be repaid over 20 years at an interest rate of 4.2% per annum, reducible monthly. Let M dollars be the monthly repayment and AN be the amount owing at the end of the at the end of the where am I? Sorry. At the end of the n months after the repayment has been made. So the first question is to show that A2 is equal to 650,000 times 1.0035 squared minus M times 1.0035. Okay. For a lot of you guys, this would mean absolutely nothing, right? So let's go through this. Okay. Let me escape. Okay. Cool. So this is like slide 72 or 73. Okay. So the very first step is to just take a look at all of our variables first, right? So our principal is $650,000. Our interest rate, so the 1 plus R part, 1 plus R will be equal to 1 plus 4.2% on 12 because it's compounded monthly. Okay, so that will be equal to 1 plus 4.2% on 12, which is 1.0035. Okay, and then our N. So it's going to take her 20 years, but N is in months. So 20 times 12 months is 240 months. Okay, I think that's all that we need at the moment. Let's get our like actual loan repayment started. Okay, so I'm going to go through things. I'll try and go as slow as I can, and make as much sense of it as I can. But please watch intently for the next few minutes because this is all brand new info to you guys. So I'm going to write the A0 being my principal. So the amount initially is my principal, which is $650,000. Sorry. Okay, my A1 will be equal to my A0 times my interest rate, right? So 1.0035. And then at the end of every month, she pays off her repayment. So minus M. So it will be equal to 650,000 times 1.0035 minus M. So I just replace my A0 with what A0 actually is. Okay, now let's move on to A2, which we're going to follow the same pattern. So A2 will be equal to A1 times 1.0035. And then at the end of the month, we're subtracting M. Okay, so it will be equal to 650,000 times 1.0035 minus M, all times 1.0035 minus M. Okay. Now I'm just going to expand that out. So times the 1.0035 to this and to this. So that gets me to 650,000 times 1.0035 squared minus m times 1.0035, and then chuck the minus m over here as well. So minus m. Now, that isn't the full way that these guys have written it. They've written it as like this is the same, but on the side over here, they take m out as a common factor. So it'll be 650,000 times 1.0035 squared minus m. I'm going to put this one to the front, so it'll just be 1 plus 1.0035, okay? Which is exactly what I asked for. So that's for I. Let's move on to II. II says show that a n is equal to 650,000 times 1.0035 to the power of n minus m times this weird looking bracket that says 1.0035 to the power of n minus 1, all on 0.0035. So the way that you could first approach this is by continuing this pattern a little bit more. Let's go to A3 and see what happens. Can we start to see a little bit more of a pattern forming? So A3 is equal to A2 times 1.0035 minus m. Okay, so it's equal to 650,000 times 1.0035 squared minus, I'm going to go back to the original notation of it being like m minus 1.0035 m, all times 1.0035, all minus m. So that gets me to 650,000 times 1.0035 cubed minus 1.0035, well, m times 1.0035 squared minus 1.0035 m times minus m. And this time I'm going to take out my common factor of m again. So 650,000 times 1.0035 squared minus m, 1 plus 1.0035 plus 1.0035 squared. Okay, so let's take a look at what happens. So the first time, it's just minus m. And the second time, it's minus like 1 plus 1.0035. And the third time, it's 1.0035 plus 1.0035 squared. So each time that we're going around, we're adding a new term, and the next one would be 1.0035 to the power of 3, right? And it'll keep going like that. So what I'm going to do is I can extrapolate what it'll look like at an. So an will be equal to 650,000 times 1.0035 to the power, oh, sorry, that's supposed to be 3, of n, because let's take a look. So when a is 1, the power is 1 over here. When a is 2, the power is 2 over here. And when a is 3, the power over here is also 3. So we're following that same kind of pattern. And then on the right-hand side, it'll be minus m, 1 plus 1.0035 plus 1.0035 squared plus blah, 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 plus 1.0035. The power, let's take a look at the power. So when n is equal to 3, the greatest power on this over here is 3 minus 1, 2. And same over here, when a is 2, the greatest power is 1. So it'll be n minus 1. Okay, All right. And now let's take a look at how we can possibly make it look a little bit more like this. Um, we've got the left-hand side part like pretty much down packed, like to the dot. The right-hand side, not so much, because we need to notice something. And the thing that we need to notice is that we have a geometric series at our hand. Um, you can see that each time we're multiplying by 1.0035. Okay. Um, so with that in mind, I could say that my first value, my A, is equal to 1, my R is equal to 1.0035, and my N, the number of terms that I have, will be equal to, so whatever the highest, well, a lot of people will think that it's just whatever the highest power is. In this case, it wouldn't quite be because um, I've got like to the power of 1, to the power of 2, blah, blah, blah. And I have an invisible times 1.0035 to the power of 0 that I need to take account for. So my n is just equal to n. Okay, so my an will be equal to 650,000 times 1.0035 to the power of n minus m times, let's do our sum of geometric series formula, which is Sn is equal to A Rn minus 1 on R minus 1. Okay, so 1 times R, 1.0035 to the power of n minus 1, all on 1.0035 minus 1. Okay, and that's going to get me to 650,000 1.0035 to the power of n minus 1.0035 to the power of n minus 1 on 0.0035. And that leaves me exactly as the question asks for. So I've just proven, or more so shown, that an is equal to 650,000 times 1.0035 to the power of n minus m, that fraction. Okay? Okay, now the next question is kind of tricky. It says find the value of m. That's a bit tricky. Like, what am I supposed to do? How do I find the value of m? The way that we go about this is by taking a look at the first part of the question. The first part of the question says that she is going to repay it by 20 years' time. Okay, so what I can write is that A, 240, because we're going in monthly repayments, right? Which will be equal to 650,000 times. By the way, because I've got my rule here, I can apply that for any value of n. So times 1.0035 to the power of 240 minus m 1.0035 to the power of 240 minus 1 on 0.0035. Okay? And that, my dear friends, will be equal to 0 because A, whatever, is the number of money, like the amount of money owing at the end of n months. So at the end of 240 months, at the end of 20 years, she should have fully repaid it, sorry. So the amount owing, $0. So now we're just going to solve for n. So I'm going to put this to my calculator because it looks a bit disgusting to try and do it algebraically. So 650,000 times 1.0035 to the power of 240, which gets me to 150,3432.015 minus m times 1.0035 to the power of 240 minus 1 on 0.0035. So 375.13 blah 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 blah. I'm going to solve for m, so I'm going to bring this over to the other side. So m times 375.134 blah 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 is equal to 150 3432.015. Going to divide this over to the other side to get my answer that m is equal to 4,007.71. So each month, Bianca has been paying $4,007.71 to the bank. Okay, that's question I. And lucky last, question IV. Question IV says, after making 120 repayments, Bianca decides that she wants to pay off the loan more quickly so that only 5 more years of repayments are needed. How much does she need to increase the value of her monthly repayment? Okay, so this is a bit annoying. I mean, it's going to be good for her, but it's going to be annoying for us bankers because now we need to do more maths. Okay, so pretty much what we need to do is we need to find the amount owing at 120 months. And what that's going to help us do is we're going to need to make a whole new pattern for whatever happens after 120 months. So first, let's do A120. A120 is equal to 650,000 times 1.0035 to the power of 120 minus, we now have m, so 4,007.71 times 1.0035 to the 120 minus 1, all on 0.0035. Okay, so the amount owing will be, give me like a sec. Okay, so it'll be $392,150.02. Sorry. Cool. So that's how much is owing in after 120 months, as I said like 20 times already. So what I'm next going to do is, because I need to make a whole new pattern to like figure out how much she needs to pay now, I am going to pretty much make this value my new P, so my principal. And so now our A0, I'm going to put in like quotation marks almost, it'll be equal to $392,150.02. So A1, we're going to go through this whole pattern making shebang again. So A1 will be equal to A0 times 1.0035 minus M. Okay, so that'll be equal to 392,150.02 times 1.0035 minus M. A2 will be equal to A1 times 1.0035 minus M. So that will be equal to 392,150.02 times 1.0035 minus M, all times 1.0035 minus M. Expand the brackets, and that gets you to 392,150.02 times 1.0035 squared minus 1.0035 m minus m. I'm going to do the same thing that was done in here, sorry, and I'm going to put the m out the front and like put it in brackets to make things a bit nicer for me in the future. Oops, going too far ahead. Minus 1.0035, oops, sorry, minus m1 plus 1.0035. Okay, A3 will be equal to A2 times 1.0035 minus m. Okay, so that's going to follow that same pattern. So 392, 150 0.02 times 1.0035 cubed minus m1 plus 1.0035 plus 1.0035 squared. Okay, now I'm going to extrapolate what my an is going to look like. Okay, so that will look like, let's take a look at our powers again. So when a is equal to 3, our highest power is equal to 3. Same thing happens at 2 and same thing happens at 1. So for the first part, I can write 392.150.02 times 1.0035 to the power of n minus m. Over here, we have our a being 1, our r being 1.0035, and just like before, our n is equal to n. So it'll be 1 times 1.0035 to the power of n minus 1 on 1.0035 minus 1. So it'll be equal to 392.150.02 times 1.0035 to the power of n minus m 1.0035 to the power of n minus 1 on 0.0035. Okay, so to actually answer the question now, we only need 5 more years. So n in this case, after 5 years, will be 12 times 5, sorry, not 6, which will be 60. So A60 will be equal to 392.150.02 times 1.0035 to the power of 60 minus m 1.003560 minus 1 on 0.0035. And now here's the thing. Just like before, when if she wants to have it finished by 60 months, then the amount owing at the 60th month should be $0. So A60 at the end of the 60th month should be 0. Okay. Now we just need to solve for m. So let's do that. 1.0035 to the power of 60. That is 483,609.53. Or we'll go 525252, just so I don't make a calculator mistake later. Minus m times 66.35, blah, 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 which will be equal to 0. I'm going to bring this to the other side, like so. So my m will be equal to 483,609.52525252. Okay, so her monthly repayments will increase to 7,257.49. Okay, that's how much it'll be increasing to, but that actually doesn't answer the question. The question actually says, by how much does she need to increase? Okay, so to properly answer the question, let's take a look at her initial amount. It was like $4,007.71. So she increases by 7257.49 minus 4007.71, which is minus 4007.71, 3,249.78 per month increase. Okay, so I know I didn't get the opportunity to properly go through a lot of questions for financial mathematics. Unfortunately, I won't be able to go through these 2 questions, but I would highly recommend trying to go through these, even if your school hasn't gone through this kind of stuff yet. Just by maybe re-watching my example that I just went through and kind of getting used to the steps so that you can work out questions 2 and 3, because it's going to be awesome if you're able to actually answer these kinds of questions before your school actually gets to it. Yeah. Okay.